All right, I wanted to show you guys how to do the activity for today. So what I'm going to have you guys do is in one of these boxes, you can read the directions here, but in these boxes here, you're going to put in your results for the two samples that you took yesterday. And here's basically what I wanted to say. We're going to go over the formula. By the time you're watching this, we probably already went over how to calculate margin of error, which is done right here in the blue. But what I wanted to show you guys was how to actually use the equation stuff in Google Docs. So here's an example. I found that the average number of pets for my sample is 1.7 with a standard deviation of 1.2 pets. There were 94 students in my sample. So here's my math for my 90% confidence interval. Maybe we'll underline that. All right. So what I did was I actually went in, and I'll just show you exactly how I did this. So I went to insert equation, and then I did margin of error equals, and then I did z, and then for the subscript right here, like if you wanted to do z sub 1, what you need to do is hit shift and then the minus key. It's like right next to the 0 and the plus key, and that'll drop you down into your subscript. You're going to want alpha, which is right here, this little Greek letter guy thing right here. All the Greek letters are in here: alpha, beta, gamma, delta, epsilon, blah, blah, blah. There's alpha. We'll just do alpha over 2 there. And then now, be careful. If you start typing here, you're still going to be in the subscript. So what you have to do is hit the right arrow key, and it'll bring you back up to the normal line, okay? Next I did times, which for me is shift 8. And then I need a fraction. So if you go to this little guy right here, the math operations, the fraction is the very first one, okay? If you need a sigma, it's right here. Check that out. Ooh, if you need a limit, that's a calculus thing. Ooh, an integral calculus thing. Take a fraction, and we're going to add a sigma, which is the Greek letter for S, so it's toward the end of the alphabet here. They have P, R, and S. I don't think they have a Q in Greek. Okay, so that's my sigma. My square root is going to be right here, and then n. And again, careful, if you start typing, you're still going to be under the radical. So hit the right arrow key. That'll bring you outside of the radical. You'll still be on the bottom of the fraction. Hit the right arrow key again. That'll bring you up to the normal line. Okay? This is the formula for the margin of error. Okay? And you're going to want to multiply by your z alpha over 2 value, which for 90% confidence interval, that's 1.645. So 1.645 times, and I need a fraction again. My standard deviation happened to be 1.2. My sample size was 94. And once I finished that, I personally went over to Wolfram Alpha and punched it in. So 1.645. You guys can use a calculator if you want, but I like Wolfram Alpha. It's pretty quick. And that's my 0.2036. 0.2036. So that's how I did that. And then I use an equation for this as well. So insert equation. Looks like you can actually type in new equation right here. So that's kind of nice. So anyway, my upper bound, oh, these are backwards. My lower bound is 1.7 minus the margin of error, right? So I think that the average number of pets held by Metro students is 1.7, but I could be off by a little bit. So I'm going to do 1.7 minus the margin of error, and then I'll do 1.7 plus the margin of error. This is my window right here. So what I'm going to say is I'm 90% confident that the actual average number of pets a Metro student has is between 1.4964 and 1.9036. I think it's 1.7, but I have to give myself a little room for error due to, sampling error, bias, all that fun stuff. So that's how you're going to set these up. I hope that helps.